The Gotthard Massif in the Swiss Alps, obstacle between north and south. For more than 130 years, trains have traveled through spiral tunnels that climb some 600 meters up to the tunnel portals at Göschenen and Airolo. The historic North-South Link, a pioneering achievement by the railway builders of the 19th century. But for the railway through the Gotthard, a new era will soon begin. In the future, the trains will travel beneath the Alpine Massif on a route with minimal gradients and generous wide radius curves. The Gotthard Base Tunnel is the world's longest tunnel. Together with the Chenery Base Tunnel, it will make the flat route through Switzerland reality and a component of the European high-speed network. Passenger trains traveling at up to 250 kilometers an hour will shorten the journey time between Zurich and Milan to less than 3 hours. 1998. The Swiss people say yes to the new rail link through the Alps, or NRLA for short. That means yes to transferring goods traffic from the roads to the railways. Yes to a flat route under the Alps and a clear commitment to a modern, forward-looking transport policy. For 11 years, the tunnelers bored and blasted two 57-kilometer-long tubes through the mountains. In 2010, they celebrate the breakthrough of the Gotthard Base Tunnel. A big day for Switzerland and Europe. It's now the turn of the railway infrastructure specialists to work round the clock on the Gotthard Base Tunnel to equip the tubes with state-of-the-art railway systems. The gigantic construction project will soon be complete. Farther south between Bellinzona and Lugano, the second section of the flat route is taking shape. The Chenery Base Tunnel, 16 kilometers long, the second major construction project of the NRLA on the Gotthard route. The work is proceeding at full speed. The first trains will travel through here in 2019. The tunnels cannot operate without approach routes. In some places, virtually the entire traffic infrastructure of roads and railways must be completely rebuilt. Bridges, underpasses, roundabouts, roads and embankments. Only by doing so can the tunnels be integrated into the railway network. The headquarters of AlpTransit Gotthard Ltd in Lucerne. Everything comes together here. As the construction principal, AlpTransit Gotthard Ltd controls and supervises the construction, costs, standards and deadlines of the Gotthard and Chenery base tunnels. The new rail link through the Alps is truly the heart of Switzerland's forward-looking transport policy. And with the Gotthard Base Tunnel, the world's longest railway tunnel is being constructed, so we're building a world record. The new rail link through the Alps is Switzerland's biggest ever environmental protection project, not only because of transferring traffic from road to rail, but also because we're attempting to give something back to nature. For example, by creating new habitats for plants and animals, or returning streams and rivers to nature. When trains start to travel through the Gotthard and Chenery base tunnels, a new era of transalpine transport will begin. We're building the future.
We are now about 2 kilometers inside the mountain. This is what they call installation location. All the works committed from the north side of the tunnel start at this point here, going south. When you look down there, you can see another tunnel.
2 Kilometer lang, das ist der Elektroschneider, die ganze Energie vom Kraftwerk für den nördlichen Teil.
This is an auxiliary tunnel about 2,000 meters long. All the energy used in the tunnel, all the electrical energy used in the tunnel is fed through that tunnel on the north side. All the energy used on the north side of the tunnel is fed through this tunnel there.
Die ganze elektrische Energie, die jetzt hier schon unter unseren Füßen durchgeht, mündet hier in dem Handtechnikgebäude 1 insgesamt 5 Innennetz, Trafostation,
all the energy that is coming through this tunnel, actually they're already in the ground here. They end in this rail infrastructure building. This is one of a total of 5 such buildings. Inside this building, the electricity is transformed and distributed throughout wherever needed in the tunnel.
Wenn wir jetzt hier gerade raufgehen, müssten wir bereits gute 600 Meter Fels durchstechen, bis wir wieder ans Tageslicht kommen. Die grösste Überhöhung über dem Tunnel ist fast 2'500 Meter.
If you start drilling a hole vertically upwards, you would need to drill for 600 meters before you could see daylight again. 600 meters. In the deepest place, you would need 2,500 meters to drill upwards to see daylight again.
Zur örtlichen Situation. Wir sind hier hingefahren, befinden uns zurzeit da. Das ist der Elektroschneider. Unser Rundgang führt uns hier durch den Stadt zum Burschentunnel. Dann werden wir hier in die Westführer gehen und dafür allein den Schlag
Okay, right now we are here. This is this auxiliary tunnel where the energy comes in, that I explained before. This is the way we drove in. And what we do now is we go in here into the west tunnel, go back here and look at this safety installations here, and then come back to here, and we pass this rail infrastructure building that you can see here, which is located here.
Ja. Alles, was wir jetzt werden, keine Tunnelbohrmaschine geschafft. Das ist alles Schlussmusik. Die beiden Tunnelbohrmaschinen sind das erste Mal da in diesen Montagekavernen zusammengesetzt. Und die Maschine ist ja 440 Meter. Dann hat sie da den Speissenschnell.
Hat sie abgebaut. meter of tunnel that we're going to see has been blasted out. Drill, explosive, blast, take out the material. In these locations, 45 meter long, the tunnel boring machines were assembled. As you remember from the PowerPoint before, the boring machine is 400 odd meters long, and this is only 45 meters. So they had to drill another hole or blast through another length here, and starting at the white point here, the tunnel boring machine was in operation. You remember that it moves in, then it spreads out and presses the drill head in front of it. Starting from the white point, the tunnel boring machine did the job. Everything that we will see has been blasted out conventional.
Das ist die Idee, wo die Grillwasser fertig sind, ist jetzt rausgekommen, wo wir nämlich 30 Kilometer lang im Süden von Dank Kaltwasser durchkommt, Wärme stabilisieren und
These pipes here used to be part of a cooling system, and exiting all water only this way. They managed to get 28 degrees inside, otherwise it would have been a lot hotter. I believe every 30 meters of mountain is equivalent to 1 degree centigrade in temperature rise. So make the calculation. At the deepest point you have 2,500 meters of mountain on top of you. Now every 300 meters is 300 meters. Sorry, mistake.
因为这个隧道渗透在下面，然后每300米的3个高度非常
You can see these two big tubes on the top of the tunnel. They were used when they blasted out the tunnel to press in fresh air and suck out the used air. When they blasted, they moved up to 130 cubic meters of air.
Das ist unser Berufsstelle, den haben wir gebraucht, dass wir uns da Teile von das man uns bewegen schon.
The bit or the bit of tunnel we are in at the moment was used to construct, to assemble all the utilities, the machinery, everything that was used in order to drill and blast out the tunnel. And it is curved because you cannot bring all the equipment like a 440 meter long boring machine to one point and have a 90-degree angle into the main tunnel. So you have to curve in order to get it. This is where we entered with the bus. First blast, November 1999. This is a modern drill machine. They, in order to blast out the radius of the tunnel needed, we need about 150 to 160 holes each 3 to 4 meters deep, which are filled with explosives in order to blast off between 3 and 4 meters. So drilling the holes, filling them with explosives, blast away takes 8 Stunden.
Das sind 3 Abschläge, also 8 Stunden.
In drilling the holes, filling them and blasting takes about 8 hours. So every 8 hours between 3 and 4 meters of tunnel come out, 24/7 gives you 10 to 12 meters every day. 8 hours for one.
So ist es 45 Millimeter Durchmesser, 3 Meter tief,
One of these holes is 45 millimeters in diameter, is between 3 and 4 meters long. How long do you reckon it takes to drill it? It takes 90 seconds to drill one hole, 90 seconds. You only have 2 drill heads. So it goes forward.
Yes, go. Das ist die heilige Barbara, Schutzpatronin der Schwicht.
The most important part in this picture is the Holy Barbara, the protector of all tunnel diggers. Remember, it doesn't look like this anymore. It's already been reconstructed, renaturized. We entered here, and it was only a small work area. It was much larger before.
Eine von der höchsten Präzision von der Vermessungsleute und Vermessungsingenieure Eindrücke. Wir haben ja 6 Durchschläge. Die grösste Abweichung 13,7 cm.
This is one of a total 6 breakthroughs. They had built it in segments. In total, there were 6 breakthroughs. The maximum distance when they drilled from either side, the maximum distance they were away, 13 centimeters. Wow. This much.
How he can measure?
GPS and laser.
We know it's a...
Yeah, but they bring it in from outside. It's GPS outside and then laser positioning.
Also Vermessung, kein GPS, nur draussen.
Nur das, ja.
Und da innen ganz konventionell mit der Kreiseltheorie.
Kreiseltheorie. Also gut, sie sind auch oben.
Ja, Computer, aber konventionell.
Yeah, so the GPS was only outside for the position, and inside was conventionally for the like construction site. And some clever brains.
Alle haben die Filme gesehen, die ich Das sind nur mal die 4 Elemente und Transit Gotthard ist die Unternehmung hauptsächlich bestehend aus den 4, die die 4 Sachen einbaut. Fahrbahn, Energieversorgung, Fahrleitung und Sicherheit.
So remember the movie when they bring in the railway infrastructure, railway, power, 50 hertz for all the installations, power, 62 for the engines, and telecommunication and safety installation.
6 Stunden Fahrt ist. In diesen 6 Stunden haben wir von der 62 in der Regel 10 Stunden müssen.
There is a total of 62 drill hits. They were drilling in 24 hours. They were drilling 2 times a 9-hour shift, is 18 hours, and they had 6 hours of maintenance. And in a 24-hour period, they, in average, had to reduce 10 of the 62 drill. They were hardened steel. It's like a wheel this size. We have seen one, and when we entered the building where we watched the presentation, there is one of these great things. It's about this size. It's one of 62.
Ein Bohrmaß von 148 Kilo und das letzte Versetzen muss
This thing is 148 kilos heavy. And you can imagine to bring it in this very narrow space, and the last bit you had to do by hand. So it's a laborious job. Heavy duty.
sehr spannend ja. In 30, 35 cm asphalt Schale.
So what you can see here is this isolation layer, hermetic seal, the 35 centimeters of concrete, and the cast. So this whole thing, you can see here the rail on the foundation where this whole thing moves, 20 meters each segment. This is a sample of the real tunnel. Only difference, the real thing, this is made of steel, and the real one is made of concrete. We are lucky. In a few weeks from now, we cannot go and see the real thing anymore. We can only see this, because the real thing will then be in operation. Yeah, that's why we come
Ganz schnell. Der zukünftige Unterricht. Nicht schwer. So wie Pisten, Kugelpisten um sich herum. Warum macht man das? Dank dieser Gummipiste können die beiden Betten, der da und so ein Bett, nicht verbinden. Man kann in irgendeinen Jahren, wenn es dann Zeit ist, lange Stück in der Aule anheben, Schienen wechseln, Stellen wechseln und das Ganze wieder versetzen. Einfach für die zukünftigen Unterricht.
For future maintenance, each and every one of these foundation blocks is in a rubber box. So it's isolated from the concrete which is poured into the whole bed. So whenever maintenance is needed, you can lift the rail out and make repairs and put it back in.
Dann haben wir das Teilstück betonieren und die Gewichtstücke. Sie können nicht in 220 Stundenkilometer der Luftkraft stoßen und dann plötzlich so austreten. Das ist der Grund, warum wir das von außen machen.
What you see beneath you is the real tunnel. Now they had to, in order to make this, they had to cover the tunnel on this short segment here. Again, when you have a train with 220 kilometers per hour, which is pushing air in front of it, you cannot let the air out in such an open space. That's why they had to cover the tunnel. It's the only moment, or the only bit of tunnel you can actually see from above, on the north side. Now we go downstairs, we sit down and watch a movie, and please, everybody of you has a water bottle, please keep drinking water.
Đóng thì là
This construction here that you see on the left side is a in order to restart consumes a lot more energy. Therefore, we have these power amplifiers and these four auxiliary wires here see to it that enough energy is available in the main wire, and the two wires below are earthing, grounding, because you don't want any. We talk 15,000 volts, and that's quite a bit. Yeah, don't signal. This black tube on the right side is the life wire of the whole tunnel. It's a leaky cable through which all communication between the train and the infrastructure is transported. It's a leaky cable GS7R or red, and it will allow us in the future to use our iPhones when we drive. Most important safety element of the whole tunnel is the handrail. The handrail is uninterrupted except when there is a door. So even if you can't see anything, you follow the handrail in any direction until the handrail stops, and then you are out. From here on, you only have to walk 50. But this one is 7.
A AUGEO é uma empresa de engenharia elétrica e eletrônica. Atua nas áreas de automação predial e industrial, com soluções para ar-condicionado, circuito fechado de TV, controle de acesso, detecção de incêndio, sonorização, entre outros. Trabalha em 5 segmentos de mercado. Soluções de grande porte envolvendo integração de sistemas. Soluções de detecção e alarme de incêndio, incluindo aplicações especiais como grandes ambientes industriais ou comerciais, galpões refrigerados, esteiras rolantes, entre outros. Soluções de automação para túneis, em particular, utilizando detecção de incêndio com a tecnologia de cabo sensor. Soluções de monitoramento e controle de centros de processamento de dados. Soluções de automação multi-site que exigem monitoramento e controle distribuído geograficamente. Mais informações podem ser consultadas em nosso site internet ou através de e-mail e telefone. Estaremos à disposição. Obrigado.